You probably recall mass per cubic volume is simply the concept of density. Without understanding time, the Poynting vector looks like just another equation. With an understanding of time, it transforms it into the Grand Unification of Physics. This is significant in so many ways, it may be breathtaking to the physicists that immediately understand this. To keep this film simple, I will not go into the details. However, physicists familiar with theories of gravity, like Gauss's law of gravity, will understand that using density, you can integrate over volume to get mass. In my opinion, the key to this integration is not to make the mistake of treating elementary particles as points of mass. Any real elementary particle mass always has some minimum volume. This is exciting, especially for any physicist that understands the implications. For example, this implies that when it comes to elementary particles, there is a maximum density. If there's a maximum density, then you cannot have an infinite density. I find this very exciting and very eye-opening. It might not be immediately obvious to you, but this simply wipes out huge areas of astronomical theory. Again, on the left side of the equation, you have concepts like energy and electromagnetism. On the right side of the equation, you have concepts like energy, mass, gravity, and density. This is a big deal, a very big deal. Let me repeat, by itself, the Poynting vector is not a grand unification theory. However, it is a unifying equation. Earlier, I mentioned the speed of light definition of time is an alternate to special relativity. And I mentioned something else is needed as an alternate to general relativity. The Poynting vector is it. Understanding time allows us to see how the Poynting vector can be used as an alternate to general relativity, thus creating a grand unification theory. In a few minutes, I will show you an alternate form of this equation, the form I prefer. You see, the equation for the Poynting vector can be reinterpreted to describe gravity. In other words, this equation combines electromagnetics and gravity. That is a very important observation. In my opinion, with appropriate constants, this is a quantum theory of gravity. Unfortunately for John Henry Poynting, he had his breakthrough overlooked. Let me give a simple example that most people will be able to visualize. Earlier I mentioned that every physicist needs to be able to clearly understand and visualize exactly how matter transforms into energy and exactly how energy transforms into matter. So let's start going through the details. Energy is equal to mass times the speed of light squared. Mass can be converted into energy, and energy can be converted into mass. The Poynting vector shows us why. Again, on the left side of the equation are the concepts of electromagnetic theory. On the right side are the concepts of mass, density, and gravity. From this, we can directly conclude matter is made of electromagnetic energy. Mass is electromagnetic. Specifically, elementary particles of matter simply are waves of electromagnetic energy. Heaviside was on the right track when he was working on electromagnetic mass. What I want to do is to start describing something that is very important about this equation. You can start with some energy, then you can add some more energy, and then the two clumps of energy can stick together to form a clump of something new, matter, or more accurately, electromagnetic mass. Before the Poynting vector will really start to make sense, you need to understand why energy sticks together. Before you can understand this idea, you first need to understand a new type of wave. So, first, We start with a pointing vector, then we use a new type of wave, and then we explain why the energy wants to stick together. Together, these concepts build on Heaviside concept of electromagnetic mass. This is how physics is unified. Waves. I'm sure you're familiar with waves. In this photograph are some simple waves on the surface of a body of water. They are created by drops of rain. Physicists describe this type of wave as a transverse wave. Waves like this are always covered in every introductory physics class. Physicists are very confident they understand waves. Therefore, I find it very amusing that there is a type of wave that physicists do not know about. Further, if I'm correct, it is by far the most common type of wave in the universe. It is the spherical wave. The spherical waves I'm about to show you are a new type of wave. Spherical waves are not new for nature, they are new for physicists. Spherical waves like this are not explained anywhere in any physics textbooks. Yet, if I'm correct, they are everywhere. Unfortunately, for some details, because spherical waves have never been described before, I was forced to come up with my own conventions to describe these waves. Well, I think I did at least a good job. I wouldn't be surprised if physicists come up with better ways of describing some of the details. If I'm correct, then I really have ventured into the center of the physics labyrinth. For a moment, imagine it that way. Imagine that I have led you to the center of the physics labyrinth. You see something there. What you see seems like it is a beautiful, brilliant sphere, like a ball of light. You immediately know it is important. However, you are not really certain what you are looking at. Again, if I'm correct, what I see there is a simple 6-symbol equation that describes these spherical waves, a special type of wave that can be found just about everywhere in the universe. So, because spherical waves play a central role in the grand unification of physics, let me take a few minutes so I can introduce them to you. First, I want your memory to link the idea of spherical waves to something that we commonly see in everyday life, the pearl necklace. So, start by imagining a pearl necklace. Imagine taking this necklace off and stretching it out. Here is a string of spherical magnets. Let me move around. Stretching out the necklace would look something like this. Next, imagine that a geometrical flat plane is moving along the necklace, intersecting each sphere along the way. Here's a simple animation of this intersection as it moves through one sphere. Personally, when I look at this animation, I think of this intersection as a solid slab moving through a solid sphere. Let's modify this animation in two ways. First, we'll use 3 spheres in a row instead of just one. Second, let us imagine that the spheres are hollow instead of being solid. In case you're wondering why they are hollow spheres instead of solid, I can't go into that one. Not now. It is a big topic. I could spend an hour on that alone. For those of you familiar with quantum physics, this topic deals with Planck's constant. Anyhow, with those two changes, the intersection would look like this. I will repeat this animation 2 more times so you can get a better look at it. Now, you might be thinking, I've never seen a wave like this before. Not true. It is highly unlikely that you have seen a wave like this on the surface of a fluid or have heard a sound wave like this. The reason is because to make a wave like this requires special circumstances. Circumstances that do not readily occur between the atoms of fluids or gases. It might interest you to know that this type of wave has been spotted countless times by scientists studying hot plasmas. Plasma scientists have called them magnetic islands, blobs, and plasmoids. Unfortunately, the plasma scientists have never correctly described this type of wave. They have come close many times. Again, you might think that you have never seen a wave like this before, but it is not true. You are looking at them right now. Actually, if I am correct, then you see spherical waves everywhere because every photon and every elementary particle is a spherical wave. If you have studied the standard model of particle physics and quantum physics, then you are comfortable with the idea of elementary particles and the idea of force carriers, the idea that forces are transmitted by some kind of particle. Here, this explanation goes beyond, or better yet, beneath that idea. This new physics is, in essence, a particle model. It explains how elementary particles are made, how, underneath it all, the particles are made of fields. It explains how these fields make a spherical wave. It explains why the energy does not dissipate. It explains why particles have some diameter. It explains why the diameter can be fuzzy. And it explains why a particle is not an infinitely small point or some type of infinitely sharp point of matter or of energy. A key detail is this: spherical waves are made with electromagnetic fields. This is why you don't see them on water. However, they can form in water. People have seen them in water around bubbles. In my opinion, spherical waves explain sonoluminescence. I wish I had more time to talk about that. I cannot imagine how they'd form in air. You probably will never hear them. Spherical electromagnetic waves can easily form in hot plasmas. That is why plasma scientists have spotted them. One of my personal goals is to daily make millions of spherical electromagnetic waves in hot plasmas in my commercial fusion power plants.